Let's discuss properties of arithmetic progressions. The first property of arithmetic progressions is that if you add a constant or if you subtract the same constant from each term, the resultant is still an AP. It still gives us the result is another AP, right? So let's say the AP, the original AP is A plus D, A plus 2D, and so on. If this is the original arithmetic progression, let's say I subtract or let's say I add k to each term. So you notice that the new series is A plus k, the second term is A plus k plus D, the third term is A plus k plus 2D, and so on, right? So notice the change that has happened. Now from the previous AP, the only change that has happened is that the first term, the A, has now changed to A plus k, right? However, the common difference, right? So this is the new AP for new AP. However, the common difference remains same. Common difference doesn't change. So new common difference is still D, right? So this is how adding a constant to each and every term changes the arithmetic progression, right? It still is an arithmetic progression. The first term changes to A plus k, everything else remains same. Now, in case of subtraction, let's say we had subtracted k from each term, we would still have gotten the same, a similar series, the only difference being that each term would now be a minus k plus d, a minus k plus 2d, and so on. So the first term would have changed to a minus k, whereas the common difference would have remained d. So that's what happens when you add or subtract a constant from each and every term. Now, let's say what happens when we multiply or divide by a constant, right? So let's say if each of the terms of an AP is multiplied or divided by a constant, let's take the original series as A plus D, A plus 2D, A plus 3D, and so on, right? And now let's multiply each term by the constant k. Now what happens is that the new series becomes AK, that's the first term. The second term is AK plus KD. The third term is AK plus 2 times KD. The next term is AK plus 3 times KD. So you notice that we still get an AP. This is still an AP. However, the first term is A into K and not A, right? The common difference is K into D, right? In place of D, the common difference is K into D. So that's how multiplication by a constant changes the original arithmetic progression. The same thing can be said for division. So if let's say instead of multiplying by K, we were dividing by K, then the first term would have been A upon K and so on, and the common difference would have been D upon K, right? So that's how multiplication of each term changes an arithmetic progression. The third property of arithmetic progressions is, so let's say I have a series 1 which goes by A1 plus D1, A1 plus 2D1, and so on, right? And let's say I have a second series S2, second arithmetic progression S2, which goes A2, A2 plus D2, A2 plus 2D2, and so on, right? So notice what happens when we add the two, right? So when we do S1 plus S2, this time we get A1 plus A2, right? That's the first term. The second term, we get A1 plus A2 plus D1 plus D2, right? So we've added A1 plus D1, A2 plus D2. We get A1 plus A2 plus D1 plus D2. Then the third term, when we add these two, we get a1 plus a2 plus 2 times d1 plus d2. So you notice now there is a trend where when we add two arithmetic progressions, we still get an arithmetic progression. So S1 plus S2, the sequence that we get by adding S1 and S2 is still an AP, right? But what has happened is that the first term of this new AP is the sum of the first two terms of the respective arithmetic progressions that have added. So the first term is now a1 plus a2, right? And the common difference is now d1 plus d2, right? So which is the sum of the common differences of the two series. Similarly, if let's say I had subtracted s2 from s1, then S1 minus S2 would have been an AP again, whose first term would have been A1 minus A2 and whose common difference would have been D1 minus D2, right? So this is how the sum and the difference of two arithmetic progressions work. Now let's take let's give you a tip on doing certain questions which involves assuming the values of let's say a few terms, a few numbers which are in arithmetic progression. So let's say the question requires us to assume three numbers in AP. So the simplest way of going about assuming three numbers in AP is you take the first number as A, right? Instead of the first term taking A, you take the middle number as A, right? And the two terms, the previous term becomes A minus D and the subsequent term becomes A plus D, right? So what we have done is we have A minus D, A and A plus D as the terms which are going to be used for the three terms of an AP, right? If let's say we had five terms, then we would have used the middle term as A, right? The other terms would have been A minus D, A minus 2D, right? Then A plus D and A plus 2D, right? So this is how we would assume five terms. However, if we are required to assume even number of terms, let's say four terms, in this case, there's going to be no middle term. We will use A minus D and A plus D as the two middle terms. And notice that the difference between them is 2D. So the first term is going to be A minus 3D and the fourth term is going to be A plus 3D. Now, how all of these assumptions they help is that when you add up all of these, you get 3A, right? So far less computation. You add all of these, the sum of this series is going to be 5A. You add all of these, the sum of this series is going to be 4A, right? So this is how sometimes making assumptions makes life easier.